Okay, good afternoon, everybody, and welcome to the last session of our conference. My name is Marie Smith. I am a Earth observation scientist from the CSIR, or the Council for Scientific and Industrial Research in South Africa, and I'm a member of the ASTRAL Consortium. So today I'm going to be presenting an overview of work being done by several researcher and consortium partners in ASTRAL, and I'll be providing you with the key contact persons of each of the topics that I'm going to be talking about today. So I should just point out that we're not specifically providing any final results of the project or any final recommendations today. We're rather just providing you with an overview of what's ongoing and what we're working towards in these topics. And then I'm going to be handing over to you for some inputs from your side, which will later assimilate into the final monitoring report. So towards that, you guys have each received a question sheet. So I'll just ask you to fill this out to the best of your abilities. And then if you would like a report of this workshop, you can fill in your email address at the bottom and we can send it to you. If not, feel free to leave out your email. Okay, so after this week, some or hopefully all of you will be familiar with the All Atlantic Ocean Sustainable, Profitable and Resilient Aquaculture, or ASTRAL project, which is a research and innovation action that started in September 2020. And it's contributing to the All Atlantic Ocean research community. Now, the ASTRAL Consortium is a multidisciplinary and multi-sectoral consortium consisting of a variety of partners situated all around the Atlantic. And we're focusing on integrated multi-trophic aquaculture, or IMTA, which can be defined as the practice which combines the cultivation of fed organisms with organic and or inorganic extractive aquaculture species to create a balanced, sustainable system. So although the ASTRAL project has a variety of work packages that focuses on the sustainability, the economic benefits, and the social and legislative aspects of IMTA, at the heart of ASTRAL are the IMTA labs, which are the aquaculture farms or the research operations with production in recirculation, flow-through, and open systems, both offshore and onshore. Other groups in ASTRAL are also developing and validating innovative technologies and solutions to support the IMTA production. And these include low-cost sensors capable of monitoring the internal systems like the biomass and the water quality, as well as the external pressures such as harmful algal blooms. So ASTRAL is also investigating potential environmental threats, and around this topic the aims are to characterize the emerging environmental changes at regional levels in relation to climate change and emerging pollutants, to identify potential environmental and climatic risks for ASTRAL IMTA labs that could affect the production sustainability, and to mitigate these risks via identification of the best monitoring practices. So in ASTRAL, we have dedicated tasks for assessing each of these topics, and each of them will produce their own their own public report at the end of the project. Here you can see the current status of the different tasks. So the climate vulnerability and the harmful algal bloom tasks have been completed, while the pathogens, microplastics tasks are still ongoing. So in the end, we will also produce a final monitoring recommendations report, which will summarize the recommendations from each of the tasks, and also include information about the technology development work package, and from regional community input, such as this workshop. So let's take a look at the work being done under the different topics. So the first task is the climate vulnerability along the Atlantic coast. And this is led by our partners at NORSE, And you can contact Nadine Goris if you have any questions on any of this work. Just as a bit of background, it has become clear that climate change is starting to threaten the sustainability of food production systems, including aquaculture. And these effects can have various impacts on aquaculture, which varies depending on the region and its climatic zones, on the production system, as well as the cultured species. Because of the sparsity of the in situ data, the study focused on large marine ecosystem regions, with the most focus on the ones that include or are adjacent to the ASTRAL IMTA systems. So it focuses on available in situ observations and databases such as SOCAT, World Ocean Database, and GLODAP. And it looked at parameters of sea surface temperature, sea surface salinity, oxygen, nitrate, pH, and partial pressure of CO2. In the task, they were also very cognizant of the potential biases that could be introduced due to the variations in the spatial and temporal density in the different data sets and regions. So they employed specific methodologies to correct and adjust for this, such as spatial aliasing and temporal aliasing. Since the task is complete, we can share some of the results. Here we show some of the trends in the large marine ecosystems where the ASTRAL IMTA labs are located. I should note that the group also submitted a publication at the end, I think at the end of last year, where they show the trends for all the large marine ecosystems, not just for the IMTA labs. And we can also note that unfortunately there wasn't enough data for nitrate to confidently estimate a trend. So this is potentially a variable that could be monitored more in future. It should also be noted that the vulnerability of aquaculture production in these environmental changes is not specifically considered, and it is because it is dependent on the sensitivity of the species to these environmental changes. So this is just a report on the general trends in the variables for the different regions. Okay, next on we move on to the second task, which is the biotic and abiotic conditions favoring harmful algal blooms, their development and their associated future risks. This task was led by Francisca Vermeulen from SAMS, and you can contact her if you had any specific interest in this topic. So we know that harmful algal blooms occur all over the world in freshwater and marine systems, and also in coastal and open ocean environments. And these blooms can be detrimental through environmental, ecological, and economical factors. They can either produce toxins or harmful metabolites. They can be harmful by producing foams, mucilage, or scums. Something that happens often in South Africa is anoxic events after a massive bloom decays. And they can also have adverse physiological impacts on higher trophic organisms, such as irritating or blocking the gills of marine animals. So the aim of the study was to conduct a literature review towards the identification of the biotic and abiotic conditions that favor the development of harmful algal blooms, and to select case studies, sites, specifically the IMTA labs, and comment on both the future HAB-related risks and the associated climate change risks and the recommended HAB-related variables and parameters that should be monitored. So to the right, you can see a part of the list of species identified at the IMTA sites that should be that the conditions would be focusing on. So some of the findings of the study specifically worked around the fact that the majority of species of concern are generally dinoflagellates, whose abundance and toxicity are strongly influenced by nutrient ratios. So in this case, it is recommended to include the sampling for certain nutrients in harmful algal bloom monitoring strategies. Other findings included that the oceanography influences when and where these blooms might occur. So it's important to monitor parameters such as the salinity, the current, the upwelling, and the stratification, and also understanding how the local oceanographic conditions might lead to these harmful algal blooms. And then having a comprehensive understanding of this, you can hopefully work towards the development of predictive models for harmful algal blooms in the different regions. It should also be noted that Earth observation is a valuable tool that helps monitoring over much higher spatial and temporal scales that is possible with in situ measurements. It is also possible to monitor the biological, chemical, and physical parameters using remote sensing. So although it cannot replace in situ monitoring, it is a very complementary method for many regions. Next up, we're focusing on one of our ongoing tasks, which is pathogens. This is a research led by LETAT, specifically Pablo Sanchez Cueto. I apologize if I don't say the name correctly, who you can contact for further information. So all of the species within the aquaculture systems are susceptible to the emerging diseases caused by various pathogenic bacteria, viruses, fungi, and parasites. And such outbreaks are unfortunately expected to increase due to climate change effects, with the open water systems being the most vulnerable. It should be noted, however, that microorganisms also play a very valuable role in the health of the cultured marine species. So in the framework of ASTRAL, it is largely unknown what effects the cultivation of a combination of macroorganisms have on maintaining and boosting the healthy microbial communities in open or closed systems. So this is taken as a valuable opportunity to enhance the sustainability strategies in this industry by using the microbiome as a key nature-based solution and as a bioindicator of the health status of a system. So this task is doing a systematic literature review about the diversity, incidence, prevalence of the different pathogens, so bacteria, viruses, fungi, and parasites, on a variety of aquaculture systems and species. It's also reviewing the state of the art of the current emerging monitoring methods for those pathogens, for instance, molecular sensors and biosensors, and their current use or potential application in these systems. They are also characterizing the microbial communities in closed system IMTA labs, so Brazil and South Africa, to be able to study the occurrence, the abundance of the possible pathogens in real-life IMTA situations. They're also looking at the sensitivity to seasonality, as well as the role of community dynamics as bioindicators. The data from all of these sources will then be integrated to identify and select the most problematic pathogen species, their abundance and presence in the labs, and the impact on aquaculture production, and potential future increase in outbreaks due to climate change. The main pathogen issues for each IMTA lab are also contextualized by how different directives and regulations categorize the health status of the cultivated organisms and pathogen risk. Also, the most problematic pathogens are assessed in terms of periodicity of outbreaks and environmental parameters which could be used to anticipate such events. These are all incorporated to define the dedicated monitoring strategies for the IMTA labs. Since this is an ongoing task, there aren't specifically any results yet, but these are at least some of the bacteria and fungi that they have identified to focus on. I'm not even going to try and pronounce any of these, but as I said, you're very welcome to contact the task lead if you are interested. So because the microbiome potential to boost the sustainable cultivation of in aquaculture, and also due to the pathogen risk, it is necessary to assess the most appropriate early detection technologies that can provide information about the health and status of the system. These recommendations are taking into account the sensitivity, the specificity, the speed, the cost, and the feasibility to implement these technologies in the field. So here you can see a summary of which technologies have been identified and the different sampling methodologies. Once again, I'm not going to try and say the names of many of these. The team are still assessing how invasive the sampling will be and the periodicity at which the sample should be taken. Lastly, we come to the ongoing task focusing on microplastics. This task is led by Alessio Gomiero from NORSE, so feel free to contact him if you're interested or if I don't describe some of the details or some of the methods in detail enough for you. So microplastics are ubiquitous in aquatic environments nowadays and become an issue and of emerging concern as they've been observed in most of the remote places of the world, such as the Arctic regions or even the abyssal trenches. And many studies have also shown that micron-sized plastic fragments have been ingested by marine organisms, including species of great ecological and economic value. Unfortunately, most modern aquaculture activities use plastic-based lines, cages or nets, as well as plastic-based biofouling and paintings. So it is important to assess these contributions to this microplastics problem. This task aims to characterize the source of the plastic pollution in terms of the diffuse inputs as long transported by current and river runoff, or as point sources in selected sea-based MTLab systems. Samples are analyzed by the best available analytical techniques using reliable sampling solutions, validated sample preparation protocols to obtain the data on the occurrence, the level, the size ranges, and the polymeric composition of plastic fragments. And here you can see some of the techniques employed. The microplastic sampling system that was developed by NORSE has traveled to most of the MTA labs already, where samples have been collected at different locations on or around the production systems. These results are currently being analyzed. We can show some preliminary evaluations of the seawater samples, which show the occurrence of 27 different polymer types. And here we show the most recurring ones, more words that are difficult to pronounce. The sites targeted as reference in the study also show the similarly representative pool of polymers, but with different accumulation levels depending on where they were collected. So in terms of ASTRAL outputs, what we can expect is each of the tasks that I've mentioned today will have individual reports on their findings and recommendations by the end of the project. We will then, we as in the last task, which I'm involved with, will then collate these results together with the findings from the ASTRAL technological development and validation work, as well as local community input from workshops such as this one, into a final monitoring recommendations report, which will be available at the end of the project. So at this point, it's over to you. So we have provided you with a survey to get your opinion on the state of the various topics that we have presented today. So in terms of microplastics, pathogens, harmful algal blooms, and I have missed one. Climate change, sorry. So we ask that you please fill these in to the best of your abilities. Like I said, there's the possibility to include your email address at the bottom if you'd like an outcome of this workshop. And please shout if you need any help with the translation of the questions or if you need any translation of the answers or understanding of what's being asked. As I said, you can contact myself, the Astral Project in general, or please come to me if you want the email addresses and names of any of the specific people in charge of the different work packages. Thank you very much.